Hi everyone, this is Mrs. J, and today we're going to talk about corresponding parts of similar figures. So we're going to start by talking about the properties of similar figures. So first of all, two figures are similar if they are two figures that have the same shape and they have the same angles, but maybe their size is different. They also could be rotated or translated, but again, they maintain that same shape. And they have these two really important properties. So the first property is corresponding angles of similar figures are congruent, as I just mentioned, and corresponding sides of similar figures are proportional, meaning they're not going to be congruent. For example, AC is clearly not the same length as XY, but they are going to be proportional in relation to the other sides. So if I am told that these two triangles are similar, and this little squiggly is the symbol for similar, what we know is that the corresponding angles are congruent. So A is congruent to X, B is congruent to Y, C is congruent to Z, and you'd match up the order from the given information. And then here's how we show that the corresponding sides are proportional. So if I create a proportion, which is just a different way of saying a fraction of these corresponding sides, AB over XY, it will be equal to the proportion of BC over YZ, which are corresponding, or AC over XZ, which are also corresponding. What's important to note here is that you have to make sure the top and the bottom of your proportion match. So what I mean by that is that you'll notice that AB, BC, and AC are all from the first triangle, and XY, YZ, and XY are all from the second triangle. We can flip them, but they all have to be flipped. So as long as all of the tops come from the same triangle and all of the bottoms come from the same triangle, it's fine. You can swap the order. Okay, so let's look at this first example together. So first, we're told that these two quadrilaterals are similar. So that means that we know that the corresponding angles are congruent, and we know that the corresponding sides are proportional. So they ask us to find X and Y. So you can see that X is here in angle C. So I'm going to look at my other figure and see if I can find the corresponding side. Another way I can do that is by looking at how it was listed. So I see that C is listed last, so I know that it corresponds with R. And since they are the angles, we can make the statement that angle C is congruent to angle R, because remember, in similar polygons, the corresponding angles are actually congruent. So then I substitute what we know, and then we can solve from here. So we'll subtract 27 from each side, and then we'll divide by 4, and we get x equals 17. And now we need to find y. So remember, for the side lengths, for the corresponding sides, they're going to be proportional, not congruent. So I see that we're trying to find AD. So I need to figure out, okay, what does that correspond with? So AD corresponds with PQ because it's second to first, so second to first. And then I'm going to see what other information I have. I know AB, so I'm going to see what that corresponds with. So AB corresponds with PS. So that means that we can create the following proportion. We can say AD over PQ equals AB over PS. So we created two proportions with corresponding sides. And now we can substitute the values that we know. So we can say 3y minus 5 over 5 equals 4 over 10. And here we can solve this by cross multiplying. So we have 10 times 3y minus 5 equals 5 times 4, which is 20. So here we can either distribute, or I could just divide both sides by 10. And since the other side is divisible by 10, let's do that. And then we can add 5 and divide by 3. So 7 over 3. Okay, let's try another example together. So here we are told that triangle ABE is similar to ACD. They ask us to find the values of x and y. So remember, in similar triangles or any shape, remember the angles are congruent that correspond. So we see that x is here in angle B. So I can see from the given information that B corresponds with C, so they are congruent. So we can say, make the statement, angle B is congruent to angle C, substitute what we know, and then we're going to solve from here. So x is equal to 12. Now to find y, remember we need to set up a proportion of the sides. So this one is a little bit trickier because you can see that y is just this little segment from D to E, but that's not actually a side length. So we can say that the side of AE is 5.6. We know this entire side length, but we know that AE corresponds to AD. So we are going to be setting up this ratio. And again, we can see that from our given information. A to E goes with A to D. So we will need to figure out how to describe this side length. So I'll talk about that in just one moment. The other information that we know is EB, and we know that EB must go with DC. So those are the corresponding sides, so they must be proportional as well. So some of them we already know just by looking at the figure. So for example, we know AE is 5.6. We know that EB is 4 centimeters and DC is 5. But now we need to find a way to describe all the way from here to here. And we can actually do that using that segment addition postulate. We can just describe it as 5.6 plus y. So here we can cross multiply again. So we have 4 times 5.6 plus y equals 5 times 5.6. If we distribute here, this gives us 22.4 plus 4y equals 28. And then we're going to keep solving for y. So the hard part is done. So we have 4y equals 5.6, and then if we divide both sides by 4, we get y equals 1.4. So again, just be careful when you're setting up your proportions that you do need to use the entire side length. And here, remember, y, which we're solving for, is only part of the total side, so we can't just use y. But again, just using segment addition postulate, we can pretty easily describe AD. Okay, let's try this last one together. So here we're told that triangle NPQ is similar to triangle NLM, and that PL, the length of this entire segment, is 8. So they would like us to find x and y. So we can see x is here. This is part of the value of angle L. It should look like this. So we know in similar triangles, corresponding angles are congruent. So angle L corresponds with angle P because they're both second listed. So they are congruent. So if we substitute, we get 3x plus 27 equals 60. Subtract 27 from each side and divide by 3. Okay, to find y, we can see that y is Pn. So we're going to need to set up a proportion of the sides. So let's start with Pn. So Pn, since it goes second to third, corresponds with Ln, so we can say over Ln equals, let's see, another length we know from our triangle on the left is Qn, and Qn, third to first, corresponds with Mn. Okay, so now we're ready to substitute the values we know. So we know that Pn is y. Now Ln, it's not listed on the figure. However, since we know the total length of PL is 8 and we know this is y, this length must be 8 minus y. So I'm going to put it in parentheses to remind us that it goes together. We cannot cancel out these y's. And then we know Qn is 3.2 and Nm is 8. So here we can cross multiply. 8 times y equals 3.2 times 8 minus y. Here we can distribute. So 8y equals 25.6 minus 3.2y. And then we can add 3.2y to each side. So we get 11.2y equals 25.6. And then we can divide both sides by 11.2. And we can do a decimal approximation. We'll round to the nearest tenth. So approximately 2.3 centimeters. Okay, that's all for today's video. Thank you so much for watching.